So now that we know how to construct a half equation, we need to learn how to combine them. And to combine them, the key thing is that the electrons must be the same. So the first thing we need to do is check that one of our equations is reduction and the other is oxidation. So one of them must have the electrons on the left, where it's being reduction. Yeah, so they're gaining. So the electrons are on the left-hand side. And one of them must show oxidation. The electrons must be on the right-hand side. The number of electrons being transferred must be the same. So you might have to multiply one or both of the half equations until they have the same number. So you've got two equations and there might be 2 electrons on the left-hand side in one and 4 electrons on the right-hand side in the other. You're going to have to multiply till they're the same. You then add them together and cross out anything that is on both sides. So we cancel down. So let's have a look at these two. We've got one with 1 electron on the right hand side and the other one with 6 electrons on the left hand side. So to be able to put these two together, I'm going to have to multiply that top one by 6. I'm going to rewrite it. What we mean by that is we just to put a 6 times everything that's there, and since there was one of each thing, in fact I'm just going to line that up a little bit better so the arrow lines up with the one above it. Okay, so now I've got my two half equations. I don't need to rewrite the other one with the chromiums in because it already had 6 electrons. What I'm going to do now is I'm going to literally, I don't need this top one anymore, I'm literally going to just add them up together. So what have I got? I've got a Cr2O7 2- and 14 H pluses and 6 Fe2 pluses and 6 electrons. And then on the other side I've got 2 chromium 3 pluses and 7 waters and 6 Fe3 pluses. So I'm just bringing everything from the two equations and 6 electrons. And then what I'm going to do is I'm going to go across, and the one thing that should definitely cancel out if you've done this correctly is there should be no electrons in your final answer. So I'm just going to rub those out. Quite often people don't even write those down because they know that they've multiplied to get rid of them. But I'm just double check now that I haven't got two of the same thing on either side, which I don't. Okay, so here's another pair. The top one's got 2 electrons in and the bottom one's got 3. Now there's no amount of multiplying of 2 that's going to give me 3. I'm going to have to multiply both of these. We need to find the first common multiple of 2 and 3. And I'm going to multiply them by 3 and 2 to make them both have 6. I'm going to rewrite them. So the top one, we're going to have 3 zincs, go to 3 zinc 2 pluses and 6 electrons. And for the bottom one, multiply everything by 2, so 2 VO2 with a 1 plus charge. Now 2 lots of 4 is 8, and our 6 electrons. And then 2 lots of vanadium 2 plus, and 2 lots of 2 is 4 waters. And then we're going to combine those, cancelling out anything that we can. So we're going to combine 3 zincs. There's nothing else on the left in the top one, so I'm going down to the bottom one. I know that the electron's going to cancel out because the whole point was to make these cancel. 3 zinc 2 pluses, 2 vanadium 2 pluses, and 4 waters. And then we're just going to go across and check that we haven't got lots of water on each side or lots of acid on each side that we can cancel down. So this is how we would combine two half equations.